Hi YouTube, continuing question 6. The arc length of the curve shown between 1 and 4 and then rotated around the x-axis for a curved surface. So for the arc length, considering the arc length formula, differentiating and squaring and applying to the integral and integrating and evaluating gives the proof 3 plus ln 4. So for the curved surface, using differentiation results from A and applying to the curved surface formula, integrating and evaluating simplifies to a curved surface of 160 over 3 pi. And the arc length. Question 7. The integration of the shaded area hyperbolic function. So considering the integration, considering parts where u equals the inverse sine x, considering the differentiation for inverse sine functions for du dx, applying parts and substituting the ln definition for sine minus 1 functions, the left hand side evaluates to here. Considering the right hand side, considering a substitution with u equals x squared plus 1, adjusting the limits, applying the substitution and simplifying and integrating, evaluates and simplifies to the proof required. So the given integral and applying parts, and the integral for the substitution, applying the substitution, and the integration of the substitution, and the exact value required, and the exact value direct. Question 8. Reduction formula to prove this expression for in, given that in is x to the power n cos x for n more than or equal to 2, and for part B showing that I4 is this expression, and for part C the exact value of I4 between 1 and 0. So for part A, considering parts where u equals x to the power n, applying the parts, the left hand side is starting to look like the formula for the proof. Considering parts again for the right hand side where u equals nx n minus 1 and du dx n minus 1 x n minus 2. Applying parts again and taking out the constant n minus 1, we can see that this gives the proof required. So for part B, using our result from A and substituting n equals 4 gives this expression, and then substituting for n equals 2 gives this expression, and substituting the result for I2 in I4 gives this expression. And then considering I0 is sin x plus c, substituting I0 into I4 gives this expression. And simplifying this expression gives the proof required. So for the exact value of I4 between 0 and 1, we can use the result of I4 directly and evaluate between 0 and 1, and evaluates to 37 sin 1 plus minus 28 cos 1 minus 0, and then adjusting, substituting for the exponential definitions for sin and cos. This then simplifies to the exact value 9 over 2e minus 65 over 2e minus 1. And the exact value of I4 between 0 and 1. Thank you for watching. I'll start the final question for this paper, the hyperbola question 9, in the next video.